Hello everyone, today I will introduce the paper named DDC Outlier Preventing Medication Errors Using Unsupervised Learning. DDC algorithm is mainly used medical treatment used to monitor the use and frequency of drugs to prevent some medical accidents. The full name of DDC is distance cellularity. The following texts are the 4 steps about how to use the DDC, and the first step and to build a distribution. The second step is to build a graph, and the next step is to calculate the similarity use the weighted PageRank algorithm, and the final step to use some serial hold to recognize that the data is outliers or inliers. So the PageRank weighted PageRank algorithm is a core step of DDC algorithm. So what is the PageRank algorithm? It's an algorithm published by Google, and this algorithm help to get all the to connect with all the information with other neighborhoods to get the probability, and the left parallel iteration is how to use the PageRank, and the right matrix is a transfer matrix. It will calculate between the distance is other vertex is neighborhoods or not. And for example, we in the first iteration, all the probability is the same, and as the second iteration, we will connect with the transfer matrix to calculate, like how do we calculate this 3, 6, and we will use the transfer matrix. So that is the basic code of the DDC algorithm, and the input is the prescribed medication P, and alpha. Alpha is using to recognize if the data is outlier or inlier, and output will have a list contain a lot of data, and it will tag 1 for inlier, or -1 is for outlier. It will have a list, right? And we can look at the 8 rules that is the core step how to use the weighted PageRank algorithm to calculate the similarity. Okay. So the weighted PageRank centrality use this and this approach use both extensions, weighted links, and weighted nodes to compute the centrality score of prescriptions. The weighted PageRank function is given by this formula, and some parameters as below. When we compare with other algorithm, other different algorithm, we found that DDC have good performance in both discrete value test and F measure. Okay, as the final result. So this is the final result, and the bubble plot on the left is showing to whether the predict data fits our expectations, and big blue bubble means it's inlier, and the red bubble means outlier. And the DDC algorithm does not have a huge advantages in running time. We can know that in the right two pictures, and the top one means it has a different symbol size, and it will the X the X is a different sample size, the Y is a different runtime, and DDC algorithm not have a good performance. But in F measures, when it have different parameter, and we will find that the F measure is good, and that is all what I want to talk about DDC algorithm. Thank you.